Here we are in section 4.1, exercises 1 through 6. With the solutions, it says to solve each system of equations, and it tells us the method it would like to see done, and that is substitution. So we've got to get one variable by itself and stick it into the other one. So starting with number 1, y equals 3x minus 7. Oh look, the y is already by itself. So we're going to take that 3x minus 7 and stick it in for the y, because y equals that 3x minus 7. So we now have this equation is 2x plus, and then this 3x minus 7 gets stuck in for the y, equals 18. There we go. Now notice what we have. We have a perfectly fine equation that we know what to do with. 2x plus 3x is 5x minus 7 equals 18. So add 7, we get 5x equals 25, and x equals, divide by 5, and we get 5. Now we take that x equals 5, and we take it and put it right back up there into the x. So we actually get y equals 3 times 5 minus 7. 3 times 5 is 15 minus 7, y equals 8. So that means our whole solution is 5, 8. Now you wonder, could we have taken that 5 and stuck it in right there? Yeah, we could have. Let's do that and see what happens. We get 2 times 5 is 10 plus y equals 8, and we solve and we still get y equals 8. We better get the exact same thing. That is the one point where x is 5 and y is 8. That combination works in both of those equations. Excellent. Number 2. 5x plus 2y equals 11, and y equals 4x minus 14. We've already got y by itself, so we take this 4x minus 14 and we'll stick it right in there. So we actually have 5x plus 2 times y, and y is 4x minus 14 to equal 11. Good. Jump that 2 through. Look, we have an equation. We know how to solve this. 5x plus 8x minus 28 equals 11. That's 13x equals, add 28 over is 39, divide by 13, and we get x equals 3. And notice that's just one of the coordinates. We need the other one, we need y. So if we take this 3 and we stick it right up there, or you could stick it there, either equation should give you the same thing. Y equals 4 times 3 minus 14. That's 12 minus 14 is a negative 2. Or if we had stuck it up here, we would get 5 times 3 plus 2y equals 11. 15, subtract it over there, and we get 2y equals a negative 4, y equals a negative 2. It doesn't matter which equation we do, it better come out to be the exact same answer, because 3, negative 2 is indeed the point that works in both of those lines. It is the intersection of them. All right, number 3. Get one of them by itself. 2y plus 5x equals 3. Y equals negative 7. Oh, hey, look, we already got the y value, so we just need to stick it in there. 2 times a negative 7 plus 5x equals 3. That's a negative 14 plus 5x equals 3. Add 14 over to the other side. We get 5x equals 17. X equals 17 over 5, which gives us the point 17 over 5, 7. Negative 7, that is. Oh, good. And that point is on both of those lines. Okay, number 4. Y equals 2/3 x minus 4, and y equals negative 2x plus 12. Both of these equations are solved for y, so we can take this guy right here and stuff him right there. 2/3 x minus 4 equals negative 2x plus 12. So since y equals this and y is that thing right there, we can stuff him right in, substitute for y. Let's times through and get rid of the fractions. Times by 3, times by 3, times by 3, times by 3. And we get 2x minus 12 equals negative 6x plus 36. Add the 6x over here, add 12 over there, and then divide by 8. X equals 6. All right, so that's most of it. Now we take that 6 and we stuff him right up there and see what we get. We get y equals negative 2 times 6 plus 12. That's negative 12 plus 12 equals a 0. Y equals 0? Did we get that if we stick him in the other one? Let's try it. Y equals 2/3. Y equals 2/3 times 6 minus 4. 2/3 times 6 is 4 minus 4. We get 0 again. So yes, 6, 0. That is the point that is on both of those lines. All right, number 5. 5x minus 7y equals 1. X equals 3. We're solved for x right down here, so we can take that 3 and stick him right up there. 5 times 3 is 15 minus 7y equals 1. Subtract 15 from both sides. We get negative 7y equals a negative 14. Oops. There we go. Negative 14 divided by a negative 7, we get y equals 2. So we have x is 3, y is 2, and that point works on both of those lines. Okay, and for the last one, number 6. 4x plus 5y equals 7, y equals 7 6x minus 9 halves. This is going to be a kind of a long one. Look at that. So we're going to take that guy and stick him right in there for the y. So y equals this. So we get 4x plus 5 times y, which is 7 6x minus 9 halves, equals 7. 4x plus 5y, and that whole thing is y, equals 7. Okay, looks like we've got a lot of simplifying to do. Let's get rid of the parentheses first. 4x plus 35 6x minus 45 halves equals 7. All right, now let's times through by the least common denominator, which is 6. So times by 6, times by 6, times by 6, times by 6, and we get 24x plus 35x minus, that'll cancel and leave a 3, 135 equals 42. 24x plus 35x, that is 59x equals, add the 135 over there and we get 177. Divide by 59, divide by 59, and oh boy, does that simplify? I think it does. I think it comes out to be 3. X equals 3. Wow, we got lucky on that guy. So now we take this 3 and we got to substitute him back up there and see what we get. Take this 3 and let's put him right there. 4 times 3 plus 5y equals 7. 12, subtract 12 over here, and we get 5y equals a negative 5. Divide by 5 on both sides, and we get y equals a negative 1. Let's double check. Subtract 12, and we get a negative 5. Divide by 5, yeah, we get negative 1. And so 3, negative 1, xy, that's the point. Let's just double check that that works. 4 times 3 is 12, plus 5 times negative 1 is minus 5 equals 7, true. If we stick 3 in here, we get 7 6 times 3 is 7 halves. Minus 9 halves is negative 2 halves, which is negative 1. It works. Good.